Hello, ladies and gentlemen, and welcome back. Today we're going to be talking about transformations, so things that are going to change our sine curve. Let's recall what we talked about with the sine curve. The sine curve takes an equation, y equals sine theta, or y equals sine x, if you will. Doesn't matter what we use for that variable. And it's going to allow us to sketch on a Cartesian plane. We talked about that. We're going to have a horizontal axis and a vertical axis. This will be positive in this direction. This will be negative in this direction. Positive in this direction. Negative in this direction. We'll allow this to be our theta axis. If I was using x, I'd call it the x-axis. This will be my y-axis. And we're going to graph all of the points theta comma sine theta. Another way to say that is theta comma y. And if I was using the x, then we would say it would be x comma y or x comma sine x. That would be a choice. We would choose what we wanted to do there. And what we learned in the last unit, or the last lesson, sorry, is that the sine theta is a graph that has a maximum value of 1, has a minimum value of -1. It has a period of 360 degrees, and something interesting happens. It hits a max, or a minimum, or a zero value every 90 degrees. We call that the critical interval. And the critical interval is CI for short. And what you do is you take your period and you just divide it by 4. Now, that'll come into play a lot more in grade 12. We don't have to do too much with that right now, but we're going to remember that every 90 degrees something interesting happens. So I'll go up by 90. 180, 270, 360, -90, -180, and I'm going to sketch this curve. It goes up to a maximum of 1, it goes down to a minimum of -1, and the sine curve starts at 0, 0. It goes up to a max, it comes down to 0, it goes down to a minimum, it comes back up to 0. It does so nice and curved like. Okay, so that's what we call concave down. This is what we call concave up. And that is your sine curve. We need to know that. We need to memorize that. We need to know it inside out. I do have a short form for memorizing it a little bit. If you take a little cross and if you put an S over it, indicating the sine curve, at 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, so that's the rotational angle going around there. We know that the sine curve is going to hit 0, a 1, back down to 0, back down to -1. And we can see this here. So sine at 0 is 0, sine at 90 is 1, sine at 180 is 0 again, sine at 270 is -1, sine of 360 will be 0. And if we was to go around again, all the way around 360 and another 90, so that'd be 360 plus 90, that would be 450, which would be 450, and you notice that we would end up at 1 again. If I was to go all the way around and over to here, so that would be another 90 from here, so that would be 540. So out here at 540, I'm coming back down to 0, and it would continue and continue and continue. We could go in the negative direction. If I went -90 degrees, so -90 degrees goes down to -1. -180 coming this way is negative, so that would be back to 0. And you can see that we have the sine curve coming in that direction. So it continues in both directions. To talk about its domain is difficult because it's an element of the real numbers. That, however, if we're talking about one cycle, then you're talking about a period, which is 360 degrees. Its range is easier to talk about. It goes between -1 and 1. And there you go. So that's the sine curve. So today we're going to be talking about transformations. We're going to do vertical stretches, we're going to do vertical compressions, and we're going to do reflections to this curve. So this curve is going to change. It's going to get vertically stretched. It's going to get vertically compressed. And it's going to get reflected. And we'll talk about what each one of those does in just a moment. We'll be right back with the next video.